Hello, thanks for joining me in today's sharing about the special algebra identities. All right. So I have seen quite a couple of students who till today they will question me whenever I tell them to use the special product method to expand or to simplify their steps. They say, teacher, why don't I just use the rainbow method all the time? Now, what do I mean by that is a lot of students will just say that, okay, since 3x plus 2 square as an example. When you split it up, it's basically like two sets of 3x plus 2 times together, right? They say, teacher, why do I need to memorize that when I can just use the rainbow method for the expansion? It's because this will not work for some kind of questions, particularly in this topic on special algebra identities. Okay, so if you don't apply it properly by heart using the three special product method that you are supposed to learn in Sec 2, you will lose out and probably not able to solve this kind of questions, okay? So we will start with question 1 for today, and of course the next sharing we will be sharing the second such common kind of question that you will probably face in your end of year exam. So to stay tuned for that. Okay, so for question 1 here, definitely when they say use special products of algebraic expressions, they are not expecting you to get an answer immediately, because it's quite obvious that if you get an answer immediately, firstly, you probably use the calculator, right? Number 1. And number 2 is it doesn't show any statements with regards to the instructions of asking you to use special products. All right, so let's get into question A. We try and basically link this to one of the special products that we learned. And typically, I like to call this special product 1, special product 2, as well as special product 3, because it's easier to say 1, 2, 3 than to say A plus B squared, that kind of stuff. You also need to memorize the expanded answer and also be able to know the pattern that comes from it. So for the first one here, when you expand A plus B bracket square, it's going to be A squared plus 2AB plus B squared. Okay, and the second one, A squared minus 2AB plus B squared. And the only difference here, some of the students still get very mixed up with regards to this. But notice that the B squared is always positive, no matter the first or second special product. The only difference is that for the first special product, if you have a plus, everything inside there is a positive, including the 2AB. For the second special product with the minus in the bracket here, the expanded answer is also negative for the 2AB. Only the 2AB has a difference on whether it's plus or minus, right? And some of the students might get mixed up with the third one as well. The third special product is the only one that has a negative B squared. A squared minus B squared. Because if you do the rainbow method and you try it out yourself, you realize that the AB portion will disappear. It will cancel each other out. And also, of course, because you use a positive B times a negative B, that's why it ends up with a negative B squared. Okay, so you need to know the expanded answer of this and to recognize them by heart, because you need to apply into numbers like that. Okay, so question 1, we want to find an easy number to that this 299.5 is close to. Can you think of a number that is close to an easy number, right? An easy number that you're probably thinking about is 300, right? But this number is less than 300, isn't it? So you got to use 300 to subtract a 0.5 before you square it, because it's 0.5 less than 300, isn't it? And because they asked us to use the special product expression method, so we are going to expand this out exactly based on what we learned in the expanded answer for our special product, right? We know that the first term is represented by A. The 300 is basically A. And then in the middle, this is because it's minus in the bracket, so you have 2 times of the A and B. Now, 2AB doesn't mean 2 plus A plus B. Some of the students have this misconception. Okay, so negative 2AB without any sign that is next to the 2AB, they will just be multiplying to each other, right? And for the ending here, the positive B square will just be basically positive 0.5 squared. At this time here, you can do a little bit of cheating by using the calculator to get your answer, because they would be not expecting that your calculation skills is so. I mean, of course, you're sitting through the calculator for both papers, right? So you should always use your calculator to help you with your answers. However, with the correct steps that show as if you are not using calculator. You get the idea, right? So 300 squared, like you don't have to really memorize how to do 300 times 300. You can just use calculator to help you, right? Or maybe you can work it out without calculator and use your calculator to check for the answer. And basically 2 times half, 2 times 0.5 will just be 1. So you're only left with a 300 in the middle. And for the ending here, 1/2 square is just be 1/4, right? All right, and though this will work out to 89700.25. And also you can double check to see if the 299.5, if you square that, does it give you the same answer? It does, right? If it give you the same answer, then it will be correct. This is just for the sake of the presentation based on the instructions, all right? Question B. So this one, which special product does it remind you of? First, second, or third? Probably the third one, right? Because you see something times something, and these two numbers seems to be close to an easy number. What's that easy number? 400, isn't it? So it's 400 plus 6 for the first term, and the second term will be 6 less than 400. So when you do it like that, it resembles the A plus B multiplied to A minus B. Agree? Yeah. So which means that my A is represented by 400, and if I expand it out, not using the rainbow method because it's slower, it's not efficient, and more steps, more calculations also means higher chance to make careless mistakes, right? So we're going to just have the overall expanded answer, which is 400 square minus 6 square, and that will be so again, we're not supposed to use calculator, so let's work out separate steps for this. Then the final answer. All right, and also double check with the calculator using the exact question here to see if it's the same, to avoid any chance of making careless mistake here, right? Once you see that, hey, it's the same answer, you should be getting your marks. Question C. 1/6 times of 31.5 square minus 28.5 square. Now, one common misconception is after students learn so many small differences between all these algebra expression, they might mistook this expression here for the second special product. That means they thought that the answer of something square minus something square is the same as like you put them in a bracket with a square on the outside. Some of the students might think that the square can just distribute to each of these terms and then you get a square minus b square. No, if you do that, you are mixing up the second special product with the third one, isn't it? It's only the third special product where you've got one set of plus and one set of minus that can create this outcome. So never ever distribute the square if you have a subtraction or the addition sign in the middle. It doesn't work this way, okay? Remember, for the first and second special product, if you have a square that is attached to outside of the bracket, you're going to get either a positive 2ab or a negative 2ab within it. Take note of that, yeah? All right, so for this question here, they don't look like easy numbers to us, right? If you should ever get an answer out confirm, they will know that you are using calculator, because who in the right mind will really do 31.5 times 31.5 unless they are so-called human calculator, isn't it? But most of us commoners, including myself, we are not, we don't have the ability, and it's very hard to show the examiner that we have, right? Unless we can prove to them. And some of the instructions that were done will not follow this using special products, right? We will not be able to link to this. All right, so we have to find some way to link to an easy number. And the easy number will basically be thinking about the 31.5 as well as 28.5. Both of these numbers are close to which easy number, easy integer is, what number can you think about? Probably think about 30, right? 30, yes. So, however, if you were to split this up into, like, let's say 30 plus 1.5 square. Some of the students might be doing this method. Are you one of them? Right, if you do something like that, you're actually making it worse, even though it is solvable, because you still need to work on like 1.5 times 1.5. Agree? So, and you have to expand these two separate parts pretty like quite complicated. There's quite a lot of tedious steps involved. And so another way to do this is to understand that since this is a square plus b square, if you put it back into the factorized form, sometimes you got to think of the box, right? And put it back into the factorized form. Instead, we are going to have two brackets. One of the bracket includes a, I mean, A is being represented by 31.5. It will be an addition for the first bracket. And for the second bracket, it's going to be a subtraction. Okay. And if that's the case, then you will have two relatively easy numbers to deal with, right? You don't have to deal with that different special product. Yeah. So this is the easiest way. So the first bracket is going to give us 60, right? Second bracket is going to give us 3. So this becomes pretty easy to deal with. 1 over 6 times 60 times 3, right? 10 times 3. We will give you 30. So then you check with the original question to see if you type the whole chunk out in the calculator, are you going to get 30 as well? Yes, right? All right. Nice job, guys. See you in the next lesson.